Good afternoon, everyone. Thank you for joining us. Today, my name is Hector Linares. I'm joined by Shireen Nisab. We're both PMs on the Azure Stack team. Today, we'll be covering business continuity, disaster recovery, architectural patterns and practices. And by show of hands, how many of you actually have had a chance to deploy Azure Stack in your environments? Excellent, excellent. And how many of you have had a chance to work with the ASDK, the Azure Stack Development Kit? Even better. So, the way we're going to split up this talk today, we'll have two different tracks. First, we'll start talking about the infrastructure side of Azure Stack. We'll cover cloud recovery, infrastructure backup, some of the HADR patterns on the infrastructure side, and then we'll jump to the application side of Azure Stack, where your users are primarily going to be deploying their workloads and putting their data. And we'll be talking about these in the context of the roles that are responsible for that part of either the infrastructure or the applications or the services. So that you've got the operator primarily responsible for operating Azure Stack. They're the first ones on hand with keyboard, working with Azure Stack, configuring Azure Stack. You can have a managed service provider, whether it's an internal set of IT teams that are working through providing services to your end users, or it could be an actual service provider that you work with that operates the stack and provides services. And finally, your cloud user. These are the folks that are using the portal to provision workloads, and so this is more of the self-service experience. So I think it's important, given the topic today, to define some key terminology that we'll be using throughout the deck. Primarily, what is a site? So the way that we will define a site in this context, it could be a building, could be a facility, could be a room, et cetera. But the idea is that you have some power, some mechanical cooling going into this environment where Azure Stack will be deployed. Now, you could have a tier 1, tier 2 data center where you don't have redundant power. If you have a more sophisticated environment, you might have 2 utility feeds, multiple backup generators, multiple cooling systems, UPSs, PDUs, et cetera, going into your site. Now, within this site, you could have one Azure Stack, and we'll define the specifics of what Azure Stack means in this context. You could have one Azure Stack deployed, or you could have many. But the idea behind what we're defining as a site today is your impact radius when there's a disaster. The idea is that when there's a catastrophe, if there's some hurricane, something that is going to wipe out an entire site, it doesn't matter how many utility feeds you have coming through it, doesn't matter how many backup generators you have through it, any number of Azure Stacks deployed in that site will go down, will go away. So when you think about disaster recovery, you're looking at disaster recovery to a different site. Now that site could be several kilometers away, hundreds of miles away. That's up to you to decide what your tolerances are as far as data loss and recovery time. But the idea is that when we define a site in this context, that entire site goes down. So let's look inside this site. Let's primarily look at how an Azure Stack integrated system is actually deployed. So we talked about having a set of UPS feeds into a set of PDUs. PDUs are power distribution units. From a distribution unit, you will have a rack. Now, this is a physical rack. We're not talking about anything logical at this point. This is all physical. Physical rack, and this is where you actually get your integrated system deployed. This is where you have your top-of-rack switches, your BMC switch, your scale unit nodes, your HLH, the hardware lifecycle host, and this is what we define now logically as a scale unit. So in terms of failures, if this site were to go away, that entire scale unit goes away. If you have multiple scale units, they all go away. So one thing to mention as we go through these patterns, we get a set of questions from customers when they realize that a scale unit is essentially bound to a rack. The question we get is, can I stretch a scale unit, one scale unit, across multiple sites? And again, sites, as I defined before, geographically dispersed. The answer is no. Azure Stack today is not supported in this configuration, and you get no benefits of what you would traditionally call a stretch cluster or a multi-site cluster. You don't get site-level awareness. You don't get workloads pinned to a site. You don't get site-level high availability. There's none of that you would traditionally, the terminology you would use for a stretch cluster, that doesn't happen with Azure Stack. So this is not a supported topology. Scale units will always be bound within a site. Okay, so let's talk about the scale unit in a rack and what levels of fault tolerance we have at this altitude. Scale unit will have 2 top-of-rack switches connected to 2 border devices. The border devices we don't control. That's what you provide in your data center. We get 4 uplinks. We connect the top-of-rack switches to those uplinks. So we have redundancy as far as connectivity. We have redundancy as far as top-of-rack switches. So one can go down, the other one will continue operating the stack. BMC switch, you have 1. So if you lose a BMC switch, you're not losing user connectivity. You are impacting some management operations. The other one is the hardware lifecycle host. You have 1 of those. You lose that, you lose some management operations. You're not impacting the usage of the scale unit. And as far as nodes, you can have up to 16 nodes. Minimal number is obviously 4, up to 16. All right, so let's look inside a node. So we're peeling the onion, going deeper and deeper. So now within a node, let's look at what levels of fault tolerance we have. So we talked about 2 top-of-rack switches. They connect to 2 NICs. Right? The 2 NICs that are inside of the scale unit are meant there for redundancy. And so if you lose a NIC, you have 2 NICs, we do the same thing for the power supply. You have 2 power supplies for redundancy as well. And in the boot drive case, you can have 2. It is optional. So if it's installed, you have a mirrored boot drive. Otherwise, you have 1. So you can lose a power supply. You can lose a NIC. You can lose a disk and still keep the server running. Obviously, if you have 1 boot drive, the server's down. If the BMC goes away, again, you're not impacting the operations of the users, of the connectivity to your end users, but some management operations won't be available until that server has been what we call through or replaced. Okay? So let's now merge the physical topology we went through and the logical topology in essentially one view. So we started with a site, and we talked about site-level disasters. So that's where scale units are deployed. You have a data center, co-location, room, row, some physical place where the rack will go. You have your rack where the scale unit will be deployed. This is the first, so the cloud now is the first logical construct inside of a rack. So for those that have Azure Stack today, your portal, your admin portal, that is the entry point for all of your operations, all of your users. That cloud is bound within that rack. That is where you have the Azure Resource Manager, ARM. This is where all your resources are actually presented. Within that cloud, you have a region. So I know that when regions are discussed in the context of Azure Stack, is it an Azure region? Is it a geographical location? When we say region in this context, we're talking about a logical concept inside of Azure Stack. And today, we deploy Azure Stack with 1 region, 1 scale unit. So within a region, I've got 1 scale unit. Within that scale unit, I've got my nodes. Within these nodes, so I'm crossing the logical physical boundaries. The last boundary is the applications and data and all of the Azure Stack services. So to reiterate, when you lose a site, you're losing all of the capacity that's contained within that set of scale units, within that scale unit, in that rack. So your region goes away, your scale units go away, your ARM instance goes away. So why is this important? Because now you have to think about how do you recover this environment when there's a disaster. And one of the key pieces you need to walk away with, especially if you haven't deployed Azure Stack, is that when there's a disaster and you only have 1 Azure Stack in a site, the idea is you have to order a new one. You order a new one, goes through manufacturing, goes through delivery, you got to get professional services on site. What if you already have the stack available? Maybe there was a software issue and you need to redeploy the software. You still need to get professional services on site. The time to recovery just to get this part is measured in weeks. So if you have an outage, if you have a site failure, if you have a meltdown in one site, and you don't have another environment, your outage is measured in weeks. So this is what needs to drive your disaster recovery planning and strategy, is that if you want to recover from any kind of site failure, you're looking at multiple deployments of Azure Stack. But let's walk through this. So I've got Azure Stack that I need to get deployed. I've ordered it, it's on site, professional services available, and now the partner, the OEM, the hardware partner, is now starting the hardware readiness phase of deploying Azure Stack. So at this point, they're bringing the rack, connecting everything, making sure that the servers are in the right firmware levels, whatever they need to do to make sure that the hardware is ready before they start software deployment. Now, in a recovery workflow, you can do two forms of recovery. Do a clean install of Azure Stack, or do what's called cloud recovery. Cloud recovery allows you to seed some of the personality back into Azure Stack, subscriptions, plans, offers, quotas, et cetera, as part of the deployment phase of Azure Stack. So this is typically a week or less. Depends on if there's any issues or anything that needs to be accounted for, maybe some additional networking, but typically partners finish this in a few days, at worst a week. So you're still not capable of deploying applications yet. At this point, you're just getting the hardware ready, software deployed, and now the partner will run through the checklist and hand over the Azure Stack instance to you. If you had PaaS services deployed, app services, SQL, et cetera, you're going through the process of reinstalling. You're restoring those PaaS services back into your Azure Stack, but this is no longer the hardware partner. Now this is you as the operator of Azure Stack. You're redeploying all your PaaS services. This could be days, depending on how many people are doing this, depending on what kind of configuration you have. This could be measured in a day or two. So you're not looking at hours. And at this point, you are capable of running workloads. Now it depends on who's actually going to do the deployment of the workloads. So the last set of phases, phase 3, phase 4, talk about IaaS VM restoration and your user data restoration. So that could be driven by the user from a self-service perspective, could be driven by a service provider on behalf of the users, and how long this takes could be hours, days, potentially weeks. But to get to this part of the restore, you've already spent weeks waiting for the hardware to arrive, for the software to be deployed on hardware that's ready, and services to be available. So I'm pretty sure this is not the ideal approach if you want to be back in business in a few hours or in a day, right? We're talking a long outage when you're doing this restoration. So let's quickly cover what we do on the infrastructure side from a backup perspective and cloud recovery. This is something that's been available since we released the product. So we have great documentation available today. So I'll cover some of the updates we've had in the last few months and around infrastructure backup. So remember, this infrastructure backup is what is going to seed the cloud recovery. And I'll cover the data that's inside of that backup. So some of the enhancements we made over the past few months, when you have backups today, you would enable them and they would be manually driven. We introduced what's called automatic backups. The minute you enable backup, they got on a schedule, determined by a frequency that you set in terms of hours, and you can also set a retention policy. That retention policy tells you, or tells the system, after a certain number of days, delete old backups. So now you can give us a share with a certain amount of capacity. We'll clean up the share over time. You don't have to keep babysitting it. So that's an automatic backup. Fully configurable through PowerShell and through the Azure Stack admin portal. We've also improved a lot of our alerts to help you with authentication issues, network connectivity issues, any other faults or issues that we might have within the system. We've made sure to enhance our alerts around this area. We've also given you the ability to enable and disable backups, meaning if you're running backups, you're running into an issue, your share is out of capacity, you can disable backups for some time and then re-enable it when you've addressed the external issue. Now, for some time, we've had these backups available and they get put on a share. There's really no way of testing if those backups are viable. So we've introduced a capability to do cloud recovery on a single node ASDK. Now, the ASDK is not meant for production. This does not mean you can take an infrastructure backup from production, run it on an ASDK, and call that production. This is purely to validate that the data is valid, that you get the subscriptions, plans, offers, quotas, RBAC back into the system, and then you delete the system. You delete the ASDK. It's not meant to actually run any production. So this is available today. We've got the documentation, supports Azure AD and ADFS, and we do this in such a way that with zero interruption to production. So we're not doing this, you can do this while you're running your production environment, and we don't actually interrupt production services. So you can restore many of these if you want to do multiple tests. Another piece that we're planning is switching over to CERT-wrapped key encryption. Today, when you provide an encryption, a symmetric key, you provide the raw key to us. We store it, we use it for encrypting of the backups. You change the key when you want to rotate. We're going to switch over to a CERT-based approach where we will use the public key inside of the CERT to wrap the keys that we use for encryption. So hopefully this makes it a little bit more secure when it comes to decrypting the data. We don't actually have that symmetric key. Sorry, we don't have to keep that symmetric key in our system. When we do this, this is not a key that we need from a public CA, so we don't need root of trust or anything else. This could be a self-signed cert. All we really care about is the public-private portions of the certificate. And the final portion we're working on, these are not available yet, is to support Azure Files. So by that I mean it's still an SMB share. It's a path that you provide, but it's hosted in Azure. So we are working on Azure Blob support, but that's going to come much later. So these are the two that we're planning for this the final two updates we're planning for this calendar year. So what is in a backup? So as of 1808, the contents of an infrastructure backup, this is not every VM. This is not every resource. So what you get here is, like I mentioned before, the personality. That's not a term, an actual term of Azure Stack. It's basically just what's used to seed the new environment that you're going to deploy. Primarily what you get in a backup is a domain controller that's internal to Azure Stack. We need that for service principals, for SIDs, for a lot of identity data that has to be restored. We keep the deployment ID. So when you restore that Azure Stack to the new environment, we keep the deployment ID that links you back up to Commerce. So you still have to register, but it's only an update to registration, not a new registration of Azure Stack. We keep the root certificate generated by the internal CA. We need that so that we can decrypt the Key Vault secrets that we restore. Without this, we wouldn't be able to do the actual Key Vault secrets restore. We keep the ADFS configurations. And then when we get to ARM, we start looking at user subscriptions, plans, offers, RP quotas. All of that comes back as part of what we call hydration. Finally, we do have some RPs that we've restored that we consider high value, low overhead for us to restore. That's the Key Vault secrets and RBAC, primarily roles and policies. Now, this is done in the context of the user, not the default subscriptions. That RBAC is recreated when you redeploy. So this is purely the user level RBAC. And finally, resource groups. This is something to note. We don't actually restore resource groups. We don't actually back them up and restore them. When you get a restore and you see resource groups, that's created automatically as part of restoring resources. So you lose metadata like tags. Just keep that in mind that for now, we don't have resource group restoration. That's something that the team is working on. But this is the snapshot as of 1808. So what I'm going to do now is switch over to Shireen, and we'll talk about HA and DR patterns.
Hi, everyone. So I'll be talking about HA and DR patterns. So we always provide that option to our customers that they can definitely do a disaster recovery from Azure Stack to Azure. And there's a list of Azure services that they can use. Like for example, there's Azure Site Recovery, there's Azure Backup, SQL IS. So we have all those options. So that's definitely something that our customers can do. Another option is if they want to do DR to their service provider. We do offer some services for that also, like SQL IS, Azure App Service, and whatever your partner backup and partner site recovery options would be. So now when you're thinking about disaster recovery, if you've deployed 2 Azure Stack stamps within the same site, you'll have high availability, but you won't have disaster recovery. So then if you're thinking about doing disaster recovery between site A and site B, where you basically have 2 Azure Stack stamps, at this point, if site A goes down, you'll definitely have disaster recovery. But at this point, when you're planning for your DR strategy, you may have some questions like, what is your data loss tolerance, or what is your downtime tolerance? And those are really important questions to ask before you're planning your DR strategy. Mostly what we've seen is the longer the distance, the higher the latency, the lower the bandwidth, and higher chances of data loss. So these are important aspects to consider before you plan for whatever will be your DR strategy. So that was a quick overview of that. Now I'll be going over basically how you can build Azure Stack deployment patterns and have HA and DR in them. I'll be starting out with the IaaS layer and eventually going into how we can have HA and DR and PaaS. So when you're thinking about IaaS, like for one thing you can think about is your SQL. So whenever you want to deploy a SQL instance in a site, like for example site A, you would definitely want it to be HA. But if it goes down, you also want to have an option that you're able to DR to like site B. And as a team, the Azure Stack team has been building some patterns for our customers to use using our existing templates which are already available in the marketplace. So I'll be walking through 2 examples and doing a demo of one. So one of the examples, we've used a SQL HA template, and the other one we've used the SQL Always On. So the first one I'll be talking through how you can do site-to-site recovery behind a VPN. So basically in your site A, you deploy the Azure Stack HA template. You have 2 SQL HA templates, sorry about that. Basically you have 2 SQL VMs within an availability set in a site A, which is definitely going to give you HA. And in order to have disaster recovery, you can configure a site-to-site VPN, have a standalone SQL replica in your site B, which will be part of an availability group, and basically that's a way you can achieve DR and HA. So we will be eventually publishing a document that will give you a step-to-step overview of how you can do this. But basically while doing it, the major learnings were that, for example, if site A goes down, make sure your site-to-site VPN is configured correctly, your availability group listeners are configured correctly, and all your accounts are synchronized like Active Directory, domain name server. And as I mentioned, we will be publishing a document hopefully in the coming weeks that will allow give our customers a step-to-step as to how they can configure this in their own environments. The second example I'll be walking through is basically distributed availability groups. This is a feature that SQL has come out in 2016, so it's relatively new. And basically what you can do is you can take the SQL Always On template, deploy one in your, for example, site A. You will have you'll have 2 instances of SQL which will be HA. That's called the primary. And you can do the same thing on your site B, where you'll have 2 instances of SQL and it'll be HA and it's called a forwarder. And these will then be connected by a distributed group. And so what distributed group is able to do, it's able to connect 2 availability groups and they don't have to be physically in the same location. So that is a great candidate for a disaster recovery scenario. So if your site A goes down, you can bring all your data back up on site B. And the major learnings that we learned while doing this was basically making sure your availability group listeners are configured correctly, your forwarder is empty, which means that your site B doesn't already have an existing database, and also that your load balancer is configured correctly so it can communicate to all your endpoints. And so I'll be doing a demo of this, so I might be referencing some of these terms like primary and forwarder, so hopefully you're able to understand. So as you can see, I deployed 2 instances. One, the SQL always on in site A, so I have 2 primary and secondary VMs, and on my site B, I have a primary and secondary VM. Now I'll show how it looks within the site A. So I have my primary SQL VM, and then I have my secondary SQL VM within site A. If you go into site B, again, I have my primary and my secondary SQL VM. Now I'll be adding a database, which I've called test7 to my primary. So I added it, make sure I back up my database, make sure I add my database to my availability group. Okay, so that was done. Now I just need to make sure that it got added to all my databases. So it got added to my primary database in site A. It got added to my secondary database in site A. Make sure it's being added to my site B, which is in a different location. Okay, so I see site test7. That means it's been added to site B. Let me just refresh this. Okay, so it's been added to my secondary on my site B also. So now I've been able to add the database test7 to all 4 SQL instances. Another thing I'll show is how you can be HA within a stamp. So I'm going to be shutting down my primary SQL VM on my primary. So basically just a few moments and my VM will be down. Okay, so now I'm going to try to connect to my VM. It should fail because I stopped it, shut it down. Okay, so that was right. Now let's see what happens. So if you can see in my availability replicas, my primary, which was initially secondary, has become primary, and my primary is no longer available. So I have HA within the stamp. So now you know how it's HA within a stamp, but you must be thinking about how can I do DR. So at any point you can always do DR, like if you have an unplanned DR scenario, you can always run this command on your site B and you'll be able to, do DR. But unfortunately in this case, you may have some data loss. But there is a way to avoid that if you have a planned DR scenario, in which case you can make sure that your site A and site B data is synchronized, and then you do your failover and make your site B as the primary. So what I would be doing is I'm running this commandlet on my site A and site B. So basically what this is doing is just synchronizing the availability group. I'll run the same commandlet on my site B. So, okay. Now I'm going to make sure that basically is the availability group synchronized, the state is synchronized. So I'll be running a new query. Okay, just running that. Okay, so if you see the synchronization state, it's all synchronized. So that means that the same data on site A is the same data on site B. But I also have to make sure that if I'm making my site B the new primary, that I make sure the state of the availability group on my site A is secondary. So I'll be running this command to do that. So this has officially made my site A as secondary. Now I'm going to go into my site B and run that command. So not this one, this would be the one. Okay, so I run this command again. And okay, so basically now you've made your site B as your primary, and all the data that was in site A is now in site B. And you're able to do that with having a distributed group across the two availability groups on the two sites. So that was basically how you can build DR and HA on the IaaS layer. Now I'll be talking about how you can do it on the PaaS layer. So the example that we'll be taking is of app service. So when you deploy an app service RP, by default, the app service components are HA, and you have the user app, and your user base database is HA. However, when it comes to disaster recovery, you would need to then deploy another instance of the app service RP on site B. And in that case, it would be HA within a STAMP, but you wouldn't necessarily be DR unless until you have a load balancer, and you would need to then also redeploy your app, and you would need to restore your user database. So another option is to have HA at the application layer. As I previously used distributed groups. We can also try to build distributed groups on the application layer to have it to be HA. So just to reiterate what I said, the learnings would be for app service, you would need to have a separate instance of the RP on each of your sites. For DR, you would need to redeploy app and restore the user database. Or we can potentially use distributed groups for the application to be HA. And we're still working through the reference architecture to figure out if this will work. And definitely when we do that, we will share it with our customers, because I think this would be a great value add for our customers. Now I'm going to hand it over to Hector to talk about recovery time planning.
Thank you, Shireen. So when we start talking about recovering your applications, you really need to think about this in the time that you can actually take as downtime, what your users require, what your business requires. So we talked about first Azure Stack and the deployment of Azure Stack, and we would consider the first Azure Stack an active site, an active configuration. This is where you would be running your workloads. If you have one, there is a way of getting backup and DR. Basically, you're going to public Azure. We already have support for Azure Site Recovery. We have support for Azure Backup. We have support from our partners who provide backup in DR that can get you to a public cloud. So if you only have one instance, you can enable protection today. However, the infrastructure itself, that is bound to that site that I mentioned before. So that software goes away in the event of a disaster. All you're failing over now are the applications, and you're restoring your user data. Now, another option is to have multiple Azure Stacks. So in this sense, you are talking about a fully deployed and registered Azure Stack. Now, if you have one already bought. Otherwise, you're waiting for a partner to deliver hardware, deploy, and that's the timeline we talked about previously. This is purely to get your infrastructure ready. So assuming that you have a secondary site up and running, now you should think about the applications. So we've worked through IaaS, we've worked through some of the PaaS layers, and these are the options that you need to start thinking through for every one of the applications going on Azure Stack. Every application doesn't need backup or DR. If it's a dev test environment, these things can go away, right? For the most part. They can go away. You obviously want to keep your templates around. You want to keep your CI/CD pipeline. All of that should be protected outside of Azure Stack. But when you actually deploy the instances, you can say that can go away. But if you've got a production workload, if you're willing to lose data and you don't have a minimal time to recovery, you can look at backup and restore. We are talking about an in-guest backup, backing up to a partner solution, and then restoring to another site. So that's typically measured in hours to days. If you need something a little bit more robust, you need replication, you need failover, you need minimal downtime, minimal data loss. Now you're looking at replication and failover. From site to site, today we only support our partner solutions, Carbonite, et cetera, that offer this today. And that would give you the ability to fail over your application because you're replicating your data. We talked about high availability, right? So the configuration that Shireen talked about is high availability within the stack. But if you have two stacks within a data center with minimal latency, you can actually have HA across these stacks as well. So you can have HA within a stack or across stacks, given that the latency tolerance is within reason for synchronous replication. Otherwise, you're looking at a replication and failover. And the last level is fault tolerance. This is, again, not provided by the infrastructure, but we're talking about partner capabilities that allow you to have two active sites that can, at any time, one site can fail, and the other site will continue working and operating with zero interruption. So that example would be coming from one of our partners called Zero Down. So the example that I have here with Zero Down, and sorry, by the way, this is a recorded video. We did have the environment available last week, so I am going to start from a recording. But basically what you're looking at here is a Azure Stack instance with Zero Down deployed. This is site 1. This is stamp 1 with the Zero Down software and your application. So that is an application that is available on your network. And then you would have the same situation on a secondary site, a secondary instance of the application with the Zero Down software running. So in this case, the product is called ZenVault. That's the application itself. And the records that are being kept here, when you enter a record, the idea is that they are both updating at the same time. The application itself does not have to know about the other instances. It's the Zero Down software sitting in front of the application that's doing the replication. So what happens now is that if I turn off or I lose my primary site, my app 1 is unavailable. Remember, these are copies of the same application, and the data is getting synchronized. So if I put in a record, the data would go to the remaining sites. It would be available. The customer would never see the downtime, even though one of the instances is down. So I can keep entering these records. It continues to get logged into the environment, and the state keeps getting built up in the application. So as I'm working through these records, now the idea would be, what happens if I need to bring back my environment or my environment's brought back up? So the first thing you want to do is, once your VM is available and your application is available, you want to bring it up, but you don't want to synchronize state just yet. You want to be able to validate that the application is available, run your smoke tests. If the application is good to go, then the idea is that you want to enable the replication from the other site back to your primary. Now, the synchronization is at the Zero Down level, and it replays all of the actions that were taken while the system was down. So once I allow that rule to let the traffic go through, application in site 1 comes back up. While that's happening, then you'll see the data start to synchronize back in. All of that data, that state is kept in the secondary site and waiting to be synchronized back to the primary. So that's a quick demo to show that we are working with a lot of our partners to ensure that we have these capabilities to protect your data, give you the confidence that you can build a strong DR plan with our partners, also with obviously Microsoft tools. And it really doesn't matter whether you're going from on-stack in your site to Azure, in your site to a service provider, or across two sites. So these are the partners that we've been working with. This is the very similar list to what we were tracking last Ignite. We've got a lot of these partners that have produced reference architecture, that have been working with partners like HPE and Cisco and others to provide you backup solutions, DR solutions. We've got partners that are now deploying syndicated items into the marketplace, so you can actually run these workloads on Azure Stack. Zero Dawn is an example of that, and others that have worked on templates. So we want to make sure that this ecosystem is robust. This ecosystem can actually respond to your needs for data protection. And it doesn't have to be within a site. It can be multiple sites to a service provider or into Azure. And what we're seeing, the trend now, and this is obviously as Azure Stack picks up, as cloud in general picks up, we're seeing now the convergence of the DevOps mentality and BCDR come into play. So we do want our customers to move to a modern mindset. Templates, parameterization. We want customers to deploy from a CI/CD pipeline, and we're seeing that motion happen. And so we're no longer just in the traditional IaaS VM restore. It is not about bringing back the disks and bringing back a VM. We're talking about full applications that can be brought back, restored, and then you're really looking at what is the piece of data that needs to bring back. Is it a database? Is it a storage account? And we've got partners that are now enabling SQL backup restore, blob storage account backup and restore. So you can actually cater the backup strategy to your application as well. But it's going to require more work than that. It's not just a partner-led initiative. This is actually what you will have to do in your environment to think through, when I develop my application, when I develop my ARM templates, how do I actually think about initial deployment versus a redeployment with a restore? How do I embed that into my scripts? How do I embed that into my automation? How do I think through bringing back a database, attaching it to a redeployed application versus something that's deployed fresh and new? So all of this mindset, these workflows are actually more on the top of the stack than the infrastructure. And one of the things that I definitely want you to walk away with is that as we work through Azure Stack, we are bringing those cloud design principles on-prem. So expecting that the infrastructure will just replicate all VMs doesn't happen in Azure, not going to happen on Azure Stack. This is just hard and fast rules moving forward with cloud on-prem. So you really want to look at how you're going to protect your VMs, your applications, and up the stack. The infrastructure itself will run your workloads, will have fault tolerance. Over time, we'll start talking about multiple scale units. We'll talk about zones, regions. That architecture hasn't been put together. So if you have those discussions with your partners today, and if you're saying, listen, I'm not ready for Azure Stack because it doesn't support multi-region. Without multi-region, I won't get HA. Not true. You can have HA today with those applications built. You can have backup and restore. You can have all these capabilities today if you decouple what the infrastructure offers from what the applications need to do. So that's one of the key learnings as we've moved forward this past year, selling systems into customer environments. That's probably one of the harder discussions, is that you have to have multiple Azure Stacks or you have to be ready to go to the cloud. Even if you have multiple Azure Stacks fully deployed, how do I get my application to the other side? Do we need GRS? GRS isn't going to help you. If you work this through in Azure as well, GRS will not protect you if you want to fail over applications. If a region fails, we get it. You'll get data on the other side. It is the insurance policy to get your data back, but not the context. The context still has to be brought back by you. A redeployment of the app, a redeployment of the VM. So with that, obviously this is Thursday. Thank you for the time that you've provided to us. I know you've been diligent in attending all of the Azure Stack sessions. Obviously, this was a 45-minute session, so I didn't go into the details of Azure Stack, but we've got great content recorded. We've got great PMs that are with us today at the booth. Any questions that come up, but this is a list of what's been presented so far this week. And with that, between Shireen and myself, thank you for your time. I hope you really enjoyed Ignite, and safe trip home. Thank you.